Okay, so here we have the exercise we did in class today. That is a 50.0 gram sample of calcium carbonate that's allowed to react with 35.0 grams of phosphoric acid. I'm sorry I didn't write the subscripts over here. How many grams of calcium phosphate can be produced? So let me write the equation for you. I'm going to write calcium carbonate, sorry for the handwriting, plus phosphoric acid. This will produce calcium phosphate. Wait, right here, plus carbon dioxide, plus water. Okay, this is a reaction. I'm going to omit the balancing parts. I'm just going to say that 3, 2, 3, and 3. Okay, so the first thing to do here is we're going to convert what we are given into moles. We have 50.0 grams of calcium carbonate, and we have 35.0 grams of phosphoric acid. So we have 50.0 grams of calcium carbonate. We convert that into moles. 1 mole of calcium carbonate is equal to approximately 101.1 grams of calcium carbonate. We cancel, and we're going to have that this is approximately equal to 0.4995 moles of calcium carbonate. I think that's what you gave me. I really don't have a calculator on me right now. Yes, I do have one. Very good. So I have 50 divided by 100.1. That is 44995. We are only allowed to use 3 significant digits, so we underline it. And now we have 35 grams, 35.0 grams of phosphoric acid. So we convert it to moles. We say that 1 mole of phosphoric acid is equal to 98.0 grams of phosphoric acid. We cancel grams with grams, and we have that 35 divided by 98 is equal to 0.3571 moles of phosphoric acid. Okay? Now, the second step is we're going to calculate the moles of product that can be produced from each reactant. Okay, so we say if we have 0.4995 moles of calcium carbonate, using equivalences, we're going to see how many moles of this substance of calcium phosphate be produced with this amount of moles of calcium carbonate. So we use equivalencies. We say that 3 moles of calcium carbonate are equivalent to 1 mole of calcium phosphate. So we divide 0.4995 by 3, and we get 0.1665 mole of calcium phosphate. Now we're going to get the number of moles of calcium phosphate obtained with this amount of moles of phosphoric acid. We have 0.3571 mole of phosphoric acid. And according to the equation, with 2 moles of phosphoric acid, you can produce 1 mole of calcium phosphate. So we cancel this. Forgot to cancel up here. And we divide 0.3571 by 2. That is equal to 0.1785 moles of calcium phosphate. So the limiting reagent, I'm going to use a different color for that. This would be the limiting reagent. Okay? So it means that that's the one we're going to be using to get the number of moles of a calcium phosphate. So we're gonna say 0.1665 moles of calcium phosphate, because that is the actual amount of calcium phosphate we're going to get, regardless of the fact that with 0.3571 moles of phosphoric acid we could get this, but we're not going to get this. What we're going to get is this one. Just like you see, if you have only 2 cups of flour, you only have 1 egg, you're going to get 35 cookies, not 70, right? So we convert these moles into grams. 1 mole of calcium phosphate, and we get the molar mass of calcium phosphate, which is approximately 310 grams of calcium phosphate. So we cancel moles with moles, and we multiply 0.1665 times 310, and what we get is 51.61 grams. That is, using the correct number as significant digits, 51.6 grams of calcium phosphate. So we already solved step number 1, or letter A. This would be letter A. Now to solve letter B, I'm going to open a new window. It says calculate the number of moles. Okay, so what we have here is the amount of excess phosphoric acid. As you remember, if you go back, let's go back here, the excess is 0.4995 moles of okay, I'm sorry, I'm gonna rephrase that. This is the amount of phosphoric acid that we have. Okay, 0.3571 moles of phosphoric acid is what we have. But are we going to use all that? No, we're not going to use all that. Now we need to know how much we're actually going to be using up. So since we're going to be using this amount of calcium carbonate, we are going to be using this amount of calcium carbonate. Let's see with what amount of phosphoric acid will this amount of calcium carbonate react. So we say, well, we have 0.4995 moles of calcium carbonate, which is the amount that is actually reacting, but we need to know with how many moles of phosphoric acid this amount of calcium carbonate is going to react. According to the equation, sorry about that, according to the equation, 3 moles of calcium carbonate will react with 2 moles of phosphoric acid. So we write that as our correction factor. So we have 3 moles of calcium carbonate will react with 2 moles of phosphoric acid. So we cancel these and we compute, we say 0.4995 times 2 divided by 3, and we get 0.333 mole of phosphoric acid is going to react with this amount of calcium carbonate. But now, what is the amount that we actually have? We have 0.357 moles. So to get the excess, we have 0.3571 mole minus the amount that we actually use, 0.333 mole. And that's going to give us the excess. That's going to be 0.3571 minus 0.333. We get 0.0241 mole. That is approximately 0.024 mole in excess. Now you can play this video over and over and over again.